Years from now, ever since I stumbled across a fairly obscure academic article by a guy named Jack Harlan, and he described the diversity within crops, all the different kinds of wheat and rice and such, as a genetic resource. And he said, this genetic resource, and I'll never forget the words, stands between us and catastrophic starvation on a scale we cannot imagine. I've been fascinated with crop diversity for about 35 years from now, ever since I stumbled across a fairly obscure academic article by a guy named Jack Harlan. And he described the diversity within crops, all the different kinds of wheat and rice and such, as a genetic resource. And he said, this genetic resource, and I'll never forget the words, stands between us and catastrophic starvation on a scale we cannot imagine. I figured he was either really onto something or he was one of these academic nutcases. So I looked a little further, and what I figured out was that he wasn't a nutcase. He was the most respected scientist in the field. What he understood was that biological diversity, crop diversity, is the biological foundation of agriculture. It's the raw material, the stuff of evolution in our agricultural crops, not a trivial matter. And he also understood that that foundation was crumbling, literally crumbling. That indeed a mass extinction was underway in our fields, in our agricultural system. And that this mass extinction was taking place with very few people noticing and even fewer caring. Now, I know that many of you don't stop to think about diversity in agricultural systems, and let's face it, that's logical. You don't see it in the newspaper every day, and when you go into the supermarket, you certainly don't see a lot of choices there. You see apples that are red, yellow, and green, and that's about it. So let me show you a picture of one form of diversity. Here's some beans, and there are about 35 or 40 different varieties of beans on this picture. Now, imagine each one of these varieties as being distinct from another about the same way as a poodle from a Great Dane. If I wanted to show you a picture of all the dog breeds in the world, and I put 30 or 40 of them on a slide, it would take about 10 slides, because there are about 400 breeds of dogs in the world. But there are about 35 to 40,000 different varieties of beans. So if I were going to show you all the beans in the world, and I had a slide like this, and I switched it every second, it would take up my entire TED Talk, and I wouldn't have to say anything. But the interesting thing is that this diversity, and the tragic thing is, that this diversity is being lost. We have about 200,000 different varieties of wheat, and we have about 200,000 to 400,000 different varieties of rice, but it's being lost. And I want to give you an example of that. It's a bit of a personal example, in fact. In the United States in the 1800s, that's where we have the best data, farmers and gardeners were growing 7,100 named varieties of apples. Imagine that, 7,100 apples with names. Today, 6,800 of those are extinct, no longer to be seen again. I used to have a list of these extinct apples, and when I would go out and give a presentation, I would pass the list out in the audience. I wouldn't tell them what it was, but it was in alphabetical order, and I would tell them to look for their names, their family names, their mother's maiden name. And at the end of the speech, I would ask, how many people have found a name? And I had never had fewer than 2/3 of an audience hold up their hand. And I said, you know what? These apples come from your ancestors, and your ancestors gave them the greatest honor they could give them. They gave them their name. The bad news is they're extinct. The good news is a third of you didn't hold up your hand. Your apple's still out there. Find it. Make sure it doesn't join the list. So I want to tell you that the piece of the good news is that the Fowler apple is still out there. And there's an old book back here, and I want to read a piece from it. This book was published in 1904. It's called The Apples of New York, and this is the second volume. You see, we used to have a lot of apples. And the Fowler apple is described in here. I hope this doesn't surprise you. Yeah, as a beautiful fruit. I don't know if we named the apple named us, but to be honest, the description goes on, and it says that it doesn't rank high in quality, however. And then he has to go even further. It sounds like it was written by an old school teacher of mine. As grown in New York, the fruit usually fails to develop properly in size and quality and is on the whole unsatisfactory. And I guess there's a lesson to be learned here, and the lesson is, so why save it? I get this question all the time. Why don't we just save the best one? And there are a couple of answers to that question. One thing is that there is no such thing as a best one. Today's best variety is tomorrow's lunch for an insect or a pest or disease. The other thing is that maybe that Fowler apple, or maybe a variety of wheat that's not economical right now, has disease or pest resistance or some quality that we're going to need for climate change that the others don't. So it's not necessary, thank God, that the Fowler apple is the best apple in the world. It's just necessary or interesting that it might have one good, unique trait. And for that reason, we ought to be saving it. Why? As a raw material, as a trait that we can use in the future. Think of diversity as giving us options. And options, of course, are exactly what we need in an era of climate change. I want to show you two slides, but first I want to tell you that we've been working at the Global Crop Diversity Trust with a number of scientists, particularly at Stanford and University of Washington, to ask the question, what's going to happen to agriculture in an era of climate change, and what kind of traits and characteristics do we need in our agricultural crops to be able to adapt to this? In short, the answer is that in the future, in many countries, the coldest growing seasons are going to be hotter than anything those crops have seen in the past. The coldest growing seasons in the future, hotter than the hottest of the past. Is agriculture adapted to that? I don't know. Can fish play the piano? If agriculture hasn't experienced that, how could it be adapted? Now, the highest concentration of poor and hungry people in the world, and the place where climate change, ironically, is going to be the worst, is in South Asia and Sub-Saharan Africa. So I've picked two examples here, and I want to show you. In the histogram before you now, the blue bars represent the historical range of temperatures, going back about as far as we have temperature data. And you can see that there's some difference between one growing season and another. Some are colder, some are hotter, and it's a bell-shaped curve. The tallest bar there is the average temperature for the most number of growing seasons. In the future, later this century, it's going to look like the red. Totally out of bounds. The agricultural system, and more importantly, the crops in the field in India have never experienced this before. Here's South Africa, the same story. But the most interesting thing about South Africa is we don't have to wait for 2070 for there to be trouble. By 2030, if the maize or corn varieties, which is the dominant crop, 50% of the nutrition in southern Africa, are still in the field, in 2030, we'll have a 30% decrease in production of maize because of the climate change already in 2030. 30% decrease of production in the context of increasing population, that's a food crisis. It's global in nature. We will watch children starve to death on TV.